Welcome to SoulPod Studio. We're not your average social network. We're a community of professionals, enthusiasts, and students taking sustainability to the next level. Join us on our journey and get inspired by Earth heroes just like you.
Welcome back to another episode of SoulPod Studio. I'm Amy Farrell, based in the Bay Area of California, and I'm joined here today with fellow Bay Area resident Jessica Maderos. Jessica is a chemical engineer, and she's worked in several different industries, but currently she's working with a really innovative company called Blue Planet. I learned about Blue Planet's carbon negative concrete aggregate at an event at Plug and Play Sunnyvale, where I got to hear Jessica present, and I was so intrigued, so I definitely wanted her to join the podcast. Welcome, Jessica.
Thank you so much for having me.
I'm so glad to have you here today. Before we really dive into the details of how carbon negative concrete is made, I just wanted to take a step back. What was it that really got you interested in designing chemical processes? I mean, I have this picture in my head of a kid who loved to experiment in the kitchen or maybe out in the backyard mixing ingredients to see what happens. But what was it really that got you interested in chemical processes?
So I remember the first, science experiment that you do in elementary school is you make that volcano eruption, right? Using baking soda and vinegar. So many students do it, and I loved that. And then I remember, as I got into middle school, I realized, I'm not so much into earth sciences. I definitely prefer physical sciences. I definitely preferred building a loop-de-loop marble roller coaster instead of dissecting frogs. So I was always exploring and learning more about what I actually like. Plus, I realized that physical science is really tied in well with math, which was definitely my strong suit. And as I got older, going into high school, the first honors class that's offered, or at least was at my high school, was honors chemistry. And I was so excited for that. I remember spending the entire summer in between freshman and sophomore year studying the periodic table, making flashcards.
Okay, I just have to say there's not a lot of people who spend their summer with the periodic table. I love it.
There was an element of we were supposed to have a test on the first day.
So you were preparing.
Yes, but I also enjoyed it. And then also, having grown up here in the San Francisco Bay Area, I'd always driven past, or my dad had always driven past, oil refineries that are around here. And this kind of sounds crazy, but I remember I was always fascinated by them, especially at night. I really felt like they looked like their own little city. And, just with all of the lights. And I was always just so curious about the inner workings of them. And I was like, I wonder what types of people get to work there. So that definitely played a part in it. But then there was also a practical part. As a first generation college student, I knew I was going to have to pay for college myself. And I knew that I was going to have to study something that I could obtain a decent paying job, to fully support myself at the end of just a 4-year degree. I knew that, going in, getting a PhD wasn't necessarily in the cards for me, at least not immediately. And so, as much as I always loved school and I would have loved to continue my education, and maybe even stay in academia, this was my path. And so I chose chemical engineering as, an 18-year-old. And I'm really glad I did.
Oh, that's amazing. So really just a combination of your interests and also your career objectives. And as you were saying, you were really concentrating not just on those 4 years as being this opportunity to learn, but also gain practical skills that you could put into action right after graduation. And I know that there's actually a lot of programs that prepare girls for STEM careers. And while it's changing, as far as I know, women are still really underrepresented in chemical engineering. I believe it's only 30%. For our listeners who are interested in pursuing a degree in this area, what are some of the words of wisdom you would share, especially for girls in high school, middle school, who are thinking about going down a path like you've pursued?
Yeah, definitely. So I definitely recommend finding a mentor, especially as someone who struggled through college without one. I can't imagine how much easier of a time I would have had. And also getting involved in clubs or even just following them before you get into, your college, if you're in high school or whatever, just following and looking at what types of clubs there are out there. Most universities have a chapter of the American Institute of Chemical Engineers, which is AICHE, or SWE, which is the Society for Women Engineers. These types of organizations are amazing. They usually have development workshops. They'll have, working professionals come in and speak on certain nights. They'll have social nights. But there's tons of resources these days. And luckily, high school students can learn about all kinds of areas like of study on their phones, right? I'm not sure exactly what types of courses other universities have, but something that was super exciting about UC Davis was right as I was leaving, the UC Davis Chemical Engineering Department started something called the Design of Coffee. It was the first elective in the chemical engineering college that was offered to anybody. Anybody at UC Davis could take it. And it seriously blew up. It instantly became the most popular elective on campus, so hard to get. I just have to imagine this helped gain even more interest in chemical engineering because you take something, so ordinary. Everybody brews coffee. Not everybody. Most people brew coffee every day. And you get into the details of the process behind it, mass and heat transfer, how to optimize for flavor and then also scale it up. And if you start to think about, wow, that happens just with coffee, I can do this with anything, like beer or cheese making. So I think, people who are on the fence about the field of study, seeking out, these kinds of courses or literature that are really approachable is amazing. But one bit of wisdom, I guess, if I can say that after only being out of school for 7 years, is really to trust that you belong in the room. I remember getting into college and, all of these fellow students, especially some of the boys, asking, the simple question of, oh, why are you studying chemical engineering? And I would get so in my head, thinking that my reasons weren't as impressive or relevant or that I might sound silly. But in reality, we were all, 18 and 19-year-olds who made a decision in high school, and so I've continued to struggle with that even up until the last few years. And I know it's something that many young women struggle with. Right now I work with such intelligent and highly educated people. And while I have far less of these moments now, I do still have some moments here and there where I have to take a step back and remind myself that while I might not have a PhD or I might not have gone to Stanford or, an Ivy League, I still belong in the room and I have so much to contribute. Many, many young women struggle with this. And I think that, as long as they know that they're willing to put in the work and always open to learning, there's no reason to doubt themselves.
I think that's incredibly inspirational for our listeners across the board. It sounds like Davis really approached engineering or chemical engineering in an innovative way. I think this coffee elective is...
It was so cool.
Yeah, who doesn't want to know the behind the scenes of making coffee? But in addition to that, it sounds like from what you've told me that you also got to dive pretty deep into your area of practice with a capstone project. I understand that, sustainability is also important at UC Davis. So how does sustainability touch chemical engineering? How is it being integrated into the field?
Definitely. My final senior project at Davis, we had to design a chemical production facility. Everything from determining what types of process units were needed. And we also were given the economics and we had to work all of that out. And basically we were told what materials we had to work with and what we needed to make. We didn't necessarily know how we were supposed to do it. So you had to research the different chemistries and the different types of unit operations that were available, right? And obviously, certain pumps have higher energy efficiencies than others. And that was something you really looked at. It was really a great first experience at process design, which is something that I love. And it encapsulated so much of what we learned in the entire curriculum. And yeah, so a big concept within chemical engineering is optimization, right? But there are so many different things that you can optimize for. And of course, each one of them has trade-offs. Luckily, though, in many cases, and the case for our process, optimizing for operating costs can also typically optimize for sustainability. The case for our process, we really wanted to recycle as much of our starting material as possible back into the process as a starting material, right? So this really served two purposes. Not only was it a more sustainable process, but it lowered our operating costs because we had to purchase less chemical. And so that's actually something that, of course, every business looks at, and that helps them to be more sustainable. But I should also mention that actually the very first course within the chemical engineering department, at least at UC Davis, is called a Professionals in Chemical Engineering course. And there's a really large emphasis on ethics in there. I remember my first research paper I ever did in college, not even just specifically the chemical engineering major, was on the ethics of GMO labeling, which was super timely. There was a proposition on the California legislature that year. And it was really the first time I learned about how many different industries chemical engineers played a role in, right? I hadn't thought much about food manufacturing before this. I always thought chemical engineers, you always go into oil and gas, right? That's what I thought growing up. But I learned in this class that that wasn't true, that there were all of these different industries. And, I also started to realize in this class that I wasn't sure that the oil and gas industry was right for me. But like I said, this wasn't actually a discouraging discovery, because I was learning that chemical engineers are needed literally in any mass production facility. Food, pharmaceuticals, building materials, those are actually all industries that I have worked in so far. And then, of course, petrochemicals, really anything you can think of. And I just liked the idea that I could still study this thing that fascinated me, that I really was interested in and I wanted to learn, but also go into a field that aligned with at least my vaguely formed ideas of my values. So I think that ethics and sustainability are really, especially I'm sure even now, because it's been 10 years since I took that course, I'm sure it's even more of an emphasis in curriculum for sure.
And I wanted to go back to what you said about your capstone project and really how you were optimizing, because I think a lot of businesses, when they think about sustainability, they think about the costs associated with it. And the example that you gave is excellent in showing that actually it can be a cost reduction strategy as well, in addition to having positive environmental outcomes. So have you seen that in some of the practical applications in some of the jobs that you've had or the roles that you've had over the last 10 years?
Oh, definitely. So actually, my first job out of college, I worked at a cheese plant. And so, I actually worked in the protein powder production facility of that plant. We would take in milk, and the first thing we would make is cheese. And then what's left from that, we would then go and we would separate out the whey and make whey protein powder. And then we would go and we would separate out the lactose powder. And finally, we're left with water because, milk is mostly water. And this company, they would actually treat their water themselves and use it for the plant washdowns, irrigating the site, and for irrigating crops that were then used to feed the cows that made the milk. And so it was completely circular. And so I loved that.
Fast forwarding to today, like I mentioned, I got to hear you speak at Plug and Play Sunnyvale. By the way, I love that place. They have so many great events. For anyone who's not familiar with the Plug and Play concept, it started in Silicon Valley and now it's global. It's great for big companies as well as startups. I got to hear you present there, and it was just so interesting to learn about carbon negative concrete. But I want to unpack this a little bit for our listeners. So if you don't mind just explaining the difference between concrete and cement, because I actually hear them used interchangeably all the time. So yeah, if you could explain that, please.
So yeah, I actually didn't even know the difference between concrete and cement until I started working at Blue Planet, which my dad would probably be kind of ashamed to hear, and probably will when he hears this, since he's always worked in construction. And I can't tell you how many days he came home exhausted from projects that included things like pouring concrete.
I love that the apple doesn't fall far from the tree, right? Like you're right working in his industry. That's amazing.
Yes, it's been so fun. He's gotten to come visit our site, and it's been so fun. It's actually definitely made us closer. But yeah, so basically you can think of concrete as like a final building material, but it's actually made up of three components: cement, water, and aggregates. So the cement itself is really what acts as like a binding agent within the concrete. If you've ever walked along a sidewalk and noticed that it's not necessarily uniform in color, you can see different shades of gray, maybe little pebbles and gravel. That's the aggregate. And then the rest of the layer is cement, and that's what's holding it all together, right? It really interconnects all of that aggregate and allows it to form that one solid slab. So the breakdown of materials in concrete, it's typically 10 to 15% cement, 15 to 20% water, and maybe 60-75% aggregates. And all of this, it fluctuates depending on the type of concrete you want to make, lightweight concrete versus heavier concrete. It just depends on the mix design.
And I guess that depends on the use case for it.
Yes, the application, totally. High rises versus bridges will have different mix designs. And, many people don't really think about it, I'm sure, but concrete is actually the most used material on the planet, or most used building material on the planet. It's the second most used material, only coming second to water. And if you start to think about it, you realize, that actually makes sense. It's buildings, highways, freeways, roadways, whatever, bridges, airports, anything in the built environment, it uses concrete. And maybe there's a distant future, much past our lifetimes, that doesn't have much use for concrete. But until then, it's super important that we start looking at how do we minimize concrete's environmental impact. Because as it stands, if concrete were a country, it would be the third highest CO2 emitter in the world. It only follows China and the US. Now, the highest carbon footprint within concrete, and it accounts for over 90% of the CO2 emissions of concrete, is the cement itself. But if you remember, cement only accounts for 10 to 15% of the mass of the concrete. So that's, really disproportionate, the CO2 emissions to the mass. The much larger portion of the material itself is the aggregates. So all of those little baby rocks making up about 75% of the concrete. So that's where Blue Planet comes in. Even though the aggregates are not the most carbon intensive material within the concrete, by making the aggregates carbon negative, you're actually able to offset all of the emissions from cement and then some, making the concrete as a whole carbon negative.
So where are you seeing the expectation of where it's going to be used?
Yeah. Actually, most aggregate worldwide is purchased by government for government-funded projects. And governments really have the power to specify carbon sequestered rock in their construction projects, right? So that's a really important lever that we have. But we also are starting to see a lot of interest in carbon negative infrastructure from private industry. A lot of tech companies are wanting to build carbon negative or at least carbon neutral data centers. And some of this interest might stem from, pressure from consumers or, forthcoming policy changes from, these governments, like I mentioned. But I think these companies also really see themselves as leaders within their industries. And I think they really want to be at the forefront of this positive change.
Amazing. It's so interesting to learn about, I guess, the entire industry and the buyers and I guess the backstory of Blue Planet. I know that the company is headquartered here in the Bay Area, kind of by San Jose in Los Gatos, but the actual physical plant is in the East Bay. And maybe you can explain a bit about the inventor of this technology and then why put the location in the East Bay? I mean, is the operation taking place there? And as you explain that, maybe you could give us a picture of what that looks like.
Right. Yeah, the process for sure. So just a bit of background on Blue Planet. Yeah, we were founded by Dr. Brent Constance. He's founded multiple companies and he has over 100 U.S. patents. And he was also previously a consulting professor at Stanford University, specializing in biomineralization. And biomineralization, basically what we are doing is we are mimicking the natural biomineralization pathway that CO2 naturally passes through, when coral is made and things like that, but we accelerate it to an industrial scale. And so, yeah, we are headquartered in Los Gatos. That is a good location for Brent and a lot of the executive team as they live down more in the South Bay. But really, the plant is located in the East Bay because it is a really good location. We found an emitter that was willing to work with us on this brand new technology. And so we have a site that is right next to an emitter, and it's also actually right next to a waterway, which is great as we start to scale up. We can barge material in and out.
Oh, right. I didn't even think about that because you're going to need to transport this material. Okay.
Exactly. Yes. Yeah, it's perfect. We have a great location. And we have great partners. And so what we do is we take the emissions that this power plant usually is, they are permitted to emit. And we take just a slipstream of that. Right now, we are not large enough to capture all of their emissions. But of course, that is the plan one day. But right now, we just take a slipstream of their flue gas, and we capture the CO2 from that. So our process takes in a couple of starting materials, but most of them are waste, right? Like I mentioned, that those emissions, those are a waste material. And then the other starting material that we use, it's actually the largest quantity of the material that we use. We need some form of geomass. And that can be steel slag, it can be returned concrete, and that's actually what we're using at this site right now. We use returned concrete. And we use that to capture alkalinity to then capture the CO2. The returned concrete itself was already a low grade or potentially waste material. And what we do with it actually upscales it into, we call it upcycled concrete aggregate. So that is now also available for reuse. And then we are actually, we regenerate the chemical within our process. So we create a circular economy. So that is why we are located in Pittsburgh currently. But what's great about Blue Planet's technology is that it can really be located anywhere that there is an emitter and an off-taker. And you think about it, that's really anywhere, because, anywhere that there is a power plant or an oil refinery or a steel mill or, even a cement plant, which that would actually be serendipitous. Those are emitters, and those are everywhere. And then same with off-takers. Any new developer, anywhere that roads and buildings and bridges are needed, there's an off-taker. So we really like to say that Blue Planet is paving the way to urban quarries. So it would also, if they are located or co-located with each of these emitters, it really reduces the amount of transportation needed too.
It sounds like it's successful, and you would then, after this pilot has gone through, I guess, couple of different phases, I guess you'll be able to roll it out in other locations in the U.S. Is that the plan?
Yeah, so we definitely are looking at scaling up to larger facilities, either on our Pittsburgh facility right now or in other locations. And we do have a team that does go out and scout different locations. And, they do what we call a sprint, and they learn on one day, like, okay, what off-takers are in this area and what emitters are this area. And they really compile an entire report of if it's feasible to be in this area or not. So yeah, those are all things that we are looking at.
Tell us just about your average day, which I'm sure there's no average day, but I kind of have this image of you with your hard hat on out in Pittsburgh, walking around the plant. But what does your day look like?
Yeah. So yeah, being such an early employee at a startup, I definitely have a lot of different looking days, but I love that. And yes, like you mentioned, some days I am putting on my hard hat and my hot pink safety vest, which is great for Barbie Girl summer. So some days I'm putting that stuff on and I'm heading out to our demonstration plant that we've built. And I am literally capturing the CO2 and turning it into carbonate aggregates. That is actually one thing I did today. And I made carbonate aggregates today. It's so rewarding to see that final product in my hand. It's just a tiny little ball, but I know that almost 50% of it by weight is CO2.
And how long does that last?
It's permanent. Yeah. So because the biomineralization process is all thermodynamically downhill, once this carbonate is formed, it can't. It is permanently sequestered as a solid, and it can't be re-emitted.
Blue Planet is a startup, as you mentioned, and your current operations, of course, it's incredible, but to really be able to get to a price point where you can scale this, maybe you can talk a little bit about the future and kind of where you see this going and when you really see it taking off.
So yeah, I'll first mention, of course, I am an engineer. I am not on our economic or business development team. But what I think is really it's about getting our name out there, getting Blue Planet recognized, getting our name out there and spreading the word and getting legislators to start thinking about carbon negative infrastructure, which they are. but really proving to them that this, demonstration that we have is scalable. I think, once we do that, we are your 2025, 2030 solution for climate change. We aren't, 2050. We're not far out. We're doing it right now, and we know it's scalable.
That's amazing. I mean, you see so many companies setting these 2050 targets, right? It's so far away, and there's so many variables. So the fact that, you can confidently say you're the 2025, 2030 solution, I mean, companies should be listening and should be reaching out, because there's a lot of work to be done to meet these pathways that they're expected to go on for carbon reduction strategies. So,
exactly.
Are you finding that people are receptive and open to using this type of technology, or is it a little bit of a wait and see?
I don't know that it's a wait and see. I think people are definitely open, but they do want it to, pass all of your regular same standards that other concrete goes through. So we do have a concrete lab on site, and we do test the compressive strength of all of our materials. Yeah, so I think that many companies just want that data, and then, to start small, right? Maybe start with a sidewalk, not a skyscraper. But yeah, no, I think that people are definitely receptive and definitely want to be, like I mentioned, at the forefront of helping to solve climate change.
I know you mentioned the founder and his incredible background, and he's an inventor, but I think when I had looked at the website, you also have someone on your team who was very instrumental in getting the LEED certification off the ground. Can you tell us a little bit about that?
Definitely, yeah. So yeah, we are very fortunate to have David Gottfried. He was one of the founders of both the U.S. and World Green Building Councils. Those organizations are what created the LEED certification system. Actually, he had a house here in Rockridge in the Bay Area that was the first of its kind home with a LEED certification. It has a plaque. You can go see it.
That's incredible, because now that's a household term, right? LEED certification is used globally.
Exactly. And yeah, so we're thrilled to have him. He is our Chief Global Impact Officer. And so he's definitely the person to talk to about, the different off-takers and how we see this going global.
Well, now you're going to have to get a little creative. So for our final question, if you could have a sustainability superpower, something that would really help change the world for the better, what would your superpower be?
That is so tricky to think about, especially as an engineer. I'm so focused on the how most of the time. And so thinking about superpowers and magic, there's a bit of a mental break there.
That's right. That's the other side of the brain for you.
Yep. But I think if I had a sustainability superpower, it would be to make all water clean. Just with the wave of a wand. So, I mean it like Great Pacific Garbage Patch, completely gone. Microplastics, like who's heard of that? No lead. I guess lead, it more leads to water infrastructure. So I guess I got to clean that up too.
So you have the wand to clean both freshwater and ocean or seawater.
Yeah, exactly. Yeah.
I love it. I love it. Well, it's been so great talking to you, Jessica. Thank you so much. And so interesting to learn about your path. And thank you for sharing about Blue Planet. We really appreciate you joining the podcast and sharing with us. Thank you.
Yeah. No, thank you so much. I was so happy to share.
SoulPod Studio is made possible by listeners like you. Join the free SoulPods platform to become a part of our virtual community of changemakers. Links to our social media, website, and platform can be found below in the show notes. If you enjoyed the show, feel free to rate and review our podcast. Thank you for listening and for your support.